Hey everyone, welcome back to another video in my series on uh, Blind 75 problems on LeetCode. Today we will be going over problem number 128, the longest consecutive sequence, which is a medium problem. I believe this is the first medium problem that I've done in this series. So far it's just been easies, but I'm trying to medium now, just to give you guys some more challenging problems, or exposure to them rather. Okay, so let's go ahead and read what this problem is about. Given an unsorted array of integers called nums, return the length of the longest consecutive elements sequence. And we need to write an algorithm that runs in linear time. So in our example right here, we have 100, 4, 200, 1, 3, 2 passed in. So this is unsorted. And we want to return the length of the longest consecutive elements sequence, which would be 4. Because right here, the longest consecutive elements we have is 1, 2, 3, 4. Therefore, its length is 4. And so in this one, we have all these numbers. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, which would go up to 9. Okay, so I'm going to be going over 3 different approaches you can do with this. First, I'll go over a brute force method. Because a sequence could start at any number in nums, we can just exhaust the entire search space by building as long a sequence as possible from every number. So the brute force algorithm doesn't really do anything clever. It just considers each number in the nums array, and then attempting to count as high as possible from that number using only numbers in nums. And then after it counts too high, current num is going to refer to a number that nums does not contain. So first, let's go ahead and get started here. And actually, I'm going to create a helper method right here. Call it array contains. And then we can just do a loop to loop through the array. And then we want to check if this current element that we're on is equal to num, in which case we can return true. So then we know it'll be in the array. Okay, and actually I forgot to return false otherwise. Okay, so now we did that. Let's see here. Okay, so first let's go and create a variable called longest streak to keep count of our consecutive numbers. Then we can go ahead and loop through the array again. And we'll go ahead and get the current num right here, just keep track of it. And we'll go ahead and create a streak inside the loop as well. And so now let's go ahead and do a while loop right here. And we want to call our array contains method with nums and the current num plus 1 to see if it's consecutive or not, if there's a consecutive number for it or not. If so, we can just do current num plus equals 1, and then this current streak also being plus equals 1. Okay, and then once we exit out of that loop, the longest streak, we can just use a math.max to get the max. of longest streak and current streak. Okay, and then we can just return longest streak. Okay, there you go. So this is a brute force method, you can see. We're going through the nums, or every number in the array, and then starting off the streak at 1, and then we're seeing if it's the next number after the number we're on, is if it's in the array or not. So like if we were currently on a 1, then we'd next be checking for if there's a 2 in the array. And if there is, then we're incrementing that, and incrementing the streak. And then it'll break out of this and it'll go on to the next number then after that. So let's go and try running this. Let's see here. I've supposed to be parentheses, not break brackets. There we go. Time limits exceeded. Okay. Actually, I believe this is happening because solution is taking quite a while to run, which makes sense since this is a brute force. So the time complexity of this is actually order of n cubed, which is not good at all. The outer loop runs exactly n times, and because current num increments by 1 during each iteration of the while loop, that will run in order of n time. Then on each iteration of the while loop, we have another order of n lookup in the array that we're doing. So this brute force algorithm is actually just 3 nested order of n loops, which comes out to be order of n cubed, which is why we're getting that time limit exceeded. Order of n cubed is very slow. Now the space complexity is actually order of 1. Since we're just working with the array we have, we're not creating any other data structure to store information. So the brute force algorithm only allocates a handful of integers, so it uses constant additional space. Okay, so let's go ahead and try a better solution. Let me make sure. Actually, this shouldn't be commented. Okay. So our next approach we can do is sorting. So if we can iterate over the numbers in ascending order, then it'll be easy to find the consecutive sequences of numbers. And to do so, we can just sort the array that we're given. So let's go ahead and see here. We won't need any helper methods with this. So let's first check if the array is empty. Return 0. Go ahead and use our sort method, which is built in. Go ahead and do the longest streak and current streak again. So now we iterate through the array, which we know is now sorted. Okay, and let's go ahead and do this check if the current number in the array is not equal to previous one. Then, oh, sorry. And then we also need a +1 right there. then we can go ahead and increment the streak by 1. Else, we can just do our same math for .max right here. Longest streak, current streak. Current streak is equal to 1. Let's see here. Should be after the for loop, so we can do a return math.max longest streak and current streak. Okay, so here, before we're doing anything, we check the base case, which is an input of an empty array. The longest sequence in an empty array is 0, so we can just return that. And then for all other cases, we sort nums and consider each number after the first, because we need to compare each number to its previous number, since this is sorted in ascending order. So if the current number and the previous are equal, then our current sequence is neither extended nor broken, so we simply move on to the next number. If they are unequal, then we must check whether the current number extends the sequence. So, for example, right here, if our current nums I is equal to nums I minus 1 plus 1, if it does, then we add to our current count and continue. Otherwise, the sequence has been broken, so we record our current sequence and then reset it to 1. So we include the number that broke the sequence. Now, it's possible that the last element of nums is part of the longest sequence, so we return the maximum of the current sequence and the longest one. Okay, so let's go and try submitting this. If nums I does not equal nums I minus 1. I'm sorry, I forgot an additional check that we need to do right here. If nums I is equal to nums I minus 1 plus 1. There we go. Then we do this current streak plus equals 1. Then else. Okay, let's try that. Let's try getting rid of that. Okay, let's try that. It's in a return statement. Let's see here. What am I doing wrong? Okay, 1 second, guys. Let me just figure this out. x -1 out of bounds for length 6. Oh, I see. We're actually supposed to be starting at I equals 1 right here, not I equals 0, since we're checking 1 behind. So if we put 0 right here, this wouldn't work. We would be going out of bounds. Okay, good. There we go. So you can see this is actually runs, so it's a lot faster. The time complexity is n log n, because the main for loop does constant work n times. So the algorithm's time complexity is dominated by the calling of the sort right here, which will run in order of n log n time for any kind of implementation. And then the space complexity could be either constant or linear. And that's because for the implementation we have here, space complexity is constant because we sort the input array in place. But if we were not allowed to modify the input array that we were given, we would have to spend a linear space to store a sorted copy of the array. So it all just depends on what the requirements for the problem are. But luckily we were able to have a constant space here. Okay, so let's go ahead and go into the final approach, which will be our fastest one. The order of n time solution that this problem is asking for. Let me make sure that's all squared away. Let's go ahead and indent that. Okay. So the third approach, the best approach to this problem, is using a hash set and then intelligently building the sequence. So the brute force solution was on the right track, but it's missing a few optimizations that are necessary to reach that order of n time complexity. So we're going to be using a hash set right here to optimize this algorithm. And you can see right here in the docs, hash set. This class implements a set interface backed by a hash table, actually a hash map instance. It makes no guarantees to the iteration order of the set, and it does not guarantee that the order remain constant. This offers constant time performance for basic operations. And then iterating over the set is proportional to the sum of the hash set's instance size, capacity. And so no duplicate elements are allowed in sets, so this will be pretty good for us to get rid of, repeating numbers like in this one. Oh, there's 2 zeros. So first, let's go ahead and create a set. It's going to be integers, obviously. And then we can just go through the array. And then go ahead and add that onto here. So go ahead and add all the numbers into the set, and the set won't include any duplicates that are in the array. So let's go ahead and set up a longest streak again. Now we can do another loop. And this time we're going through the set. And so let's go into check if the set doesn't contain the previous number of what we're currently on. Sorry about that, I sneezed. Okay, then we want to set the current num equal to num, and then our current streak. Go ahead and set these up again, equal to 1. Should actually also be in the for loop. Let's go into a while. And set contains the current num that we're on plus 1. Go ahead and increment that current num, and then the streak as well. So it was very similar to the brute force solutions. You can see a lot of the same things we're doing, but the hash set definitely helps get rid of the nested loops. So now we can just do math.max of longest streak and current streak. Then we can just return longest streak. Let's go and see if that works. Yep, there you go. So what we're doing right here is this optimized algorithm contains only 2 changes from that brute force approach we did earlier. We're storing the numbers inside of a hash set right here to allow for constant time lookups, since there's only one of each kind of element in the set, so our lookups are constant. And we only attempt to build sequences from numbers that are not already part of a longer sequence. So this is accomplished by first ensuring that the number that would immediately precede the current number in a sequence is not present, as that number would necessarily, be part of a longer sequence. So our time complexity here is order of n. Although the time complexity appears to be quadratic due to the while loop nested within the for loop, if you look at it closely, this is actually linear, because the while loop is reached only when current num marks the beginning of a sequence. In other words, when current num minus 1 is not present in nums. The while loop can only run for n iterations throughout the entire run of the algorithm. So this means that despite looking like it's order of n times n complexity, the nested loops actually run in order of n plus n, which still comes out to order of n time. All other computations occur in constant time, so this overall runtime is linear. Now, our space complexity is also order of n, because in order to set up those constant time lookups in the set, we have to allocate linear space for a hash table to store the order of n numbers in nums. Other than that, the space complexity is identical to that of the brute force solution. Okay, so since I've shown you the approaches here, I will show you just the best solution in Python instead of going through all those approaches and all the languages, since you guys kind of get the idea now. We'll just go for the best solution now in the languages. So in Python, instead of a hash set, it's just a set. So let's go ahead and do longest streak equals 0. We want to create another set, which is going to be a set version of our array. And now we want to go ahead and iterate through that set. If num minus 1 is not in our num set, we can go ahead and set current num equal to num, and current streak equal to 1, so we know where we're starting at. So we'll go ahead and starting with the num. And then similarly, we do a while loop while current num plus 1 is in the num set. Then current num plus equals 1, streak plus equals 1. And then inside this while loop, longest streak is again just the max of longest streak and current streak. And then we can just return longest streak in the end. It's very similar to the Java solution. And there you go. Okay guys, well, let me see here. Maybe I want to... Yeah, I think that's fine. Yeah, I think this is fine. I won't do a C++ solution this time around, since you guys kind of already get the idea now. So that will be it for today's video. Thank you guys for watching. Hope you learned something. And I will see you guys in my next video of the Blind 75 series. So take care, and bye.